let's integrate some inverse trig functions. Know these three integrals. Be able to just memorize them, and we will work with them until you're very familiar with them. All right, if you have an integral of the form du divided by the square root of a squared minus u squared, that's the inverse sine of u over a plus c. While the integral of du divided by u, so if you have this u on the outside, then you know you're looking at this form, or probably this form. So du divided by u, square root of u squared minus a squared, is 1 over a inverse secant. Absolute value of u over a, and this absolute value is very important, so make sure you don't forget it. You don't have to use it if you can show me that the function is always positive. And then the integral of du divided by a squared plus u squared is 1 over a inverse tangent of u over a plus c. To do these, I want you to identify the form, all right, and write that down with solution, okay? And then you need to identify u, du, and a in all of these problems. And then you need to manipulate your integral, P-U-L-A-T-E. Manipulate your integral to get it in the correct form, and then substitute back in. And then simplify. And only simplify, S-I-M-P-L-I-F-Y? No, Y-F-Y. Simplify. All right. Now let's look at this one. This is the integral of dx over 4 minus x squared. If I let u equal x, du is dx. If I let a equal 2, a squared is 4. Then you see I've got an integral of the form du divided by the square root of a squared minus u squared. And I know that this integral, this integral is the inverse sine of u over a plus c. So I know this is true. Now I'm going to rewrite this equation right here. I probably shouldn't put that equal sign there. I'm going to rewrite this equation as the integral of dx divided by the square root of 2 squared minus x squared. So this becomes the inverse sine of u, which is x, divided by a, which is 2, plus c. Let's try this one. Now, you can tell I've already been playing with this one. This is the integral of, let's see, dx divided by x, square root of 4x squared minus 9. So you know that the integral of du divided by u, square root of u squared minus a squared, is 1 over a secant inverse of the absolute value of u over a plus c. Okay, cool, we're in good shape. So let's see, let's let u equal 2x. And then du is 2 dx. Now I'm going to let a equal the square root of this, so a squared is 9, so a is 3. Now, I need to get this whole thing in the correct form, and it's obviously not. If I have a 2 here and a 2 here, those will cancel, but now I have u here and here. I have u squared minus 9. So I'm going to write this as 2 dx divided by 2x times the square root of 2x squared minus 3 squared. Okay, do you see how I did that? So now, this becomes 1 over a, and a is 3, the inverse secant of the absolute value of u, which is 2x, divided by 3 plus c. All right, now let's look at this one. The integral of dx over 2 plus 9x squared. Now this is of the form du divided by a squared plus u squared. And I know that that integral is 1 over a times the inverse tangent of u over a plus c. All right, now this is not in such a nice, easy form. Here is u squared, so let me let u equal u 3x, and then du is 3 dx. Let me let a squared equal 2, so a is the square root of 2. All right, so we are going to need to do some manipulation here. I need du up here, so this is 3, so I need to multiply by a third here. Okay, now let me rewrite this. This is 1/3 times the integral of 3 dx divided by the square root of 2 squared plus 3x squared. All right? So now this is 1/3 times 1 over a, and a is the square root of 2, inverse tangent of u, and u is 3x, divided by a, which is the square root of 2, plus c. Now remember I told you you have to simplify only if it makes your life easier. And I got to tell you, I can't handle having radicals in the denominator. So this becomes the square root of 2 over 6 inverse tangent of 3 square root of 2x over 2 plus c. All right, you give it a go. Stop the tape. When you're done, turn it back on. And we've got just 1 or 2 more little things to do. All right, sometimes you just need to rewrite. All right, this one doesn't have any nice form, but what if I write it like this? What if I write as the integral of x over the square root of 4 minus x squared plus dx plus the integral of 2 dx divided by the square root of 4 minus x squared. When you do this, now you're in a situation where you can just do them separately. So let me look at the integral of x dx over 4 minus x squared square root. Now this one is, let me do a u substitution, where if u is 4 minus x squared, du is negative 2x. So I can put negative 2 here, 1 over negative 2 out here. And this integral becomes minus 1/2. Now, this is the integral of u to the negative 1/2 du. So it's negative 1/2 u to the 1/2 divided by 1/2. So simplifying this, it gets a little messy, I know that. So this is negative, that cancels the square root of u, which is 4 minus x squared. Now folks, it's perfectly okay to do one part of this at a time. I'm going to come over here and I'm going to do the second part. So that was the first integral. So now I'm going to integrate 2 dx divided by the square root of 4 minus x squared. Now this one is in the arc sine form. All right, so if I let u equal x, du is dx, and now I'm going to let a squared equal 4, so a is 2. And now I'm going to rewrite this as 2 times the integral of dx divided by the square root of 2 squared minus x squared. So this becomes 2 times the inverse sine of x over 2. So when I add these two together, and I'm going to do that in green, my integral of x plus 2 divided by the square root of 4 minus x squared dx becomes minus 4 minus x squared square root plus 2 inverse sine x over 2 plus c. Now, see if you can do this one. Give it a go. And when you're done, stop the tape.